Hey everybody, the purpose of this video is to sort of walk you through the guided notes that you didn't get to see that first and fourth period did. So we're going to start by talking about what this chapter is going to be about. This chapter is going to be about things called rational expressions, which are essentially fractions that have polynomials on top and bottom. The first part of the chapter, we're going to be doing operations with them, which means we're going to be simplifying them, adding them, multiplying, dividing, and subtracting. So we're going to start by simplifying. So since these things are basically fractions, they just have variables in them, we need to go back and remind ourselves what the rules are for fractions, because a lot of times we use calculators so heavily that we forget what the actual fraction rules are. So the first thing is remembering how to simplify fractions. So this first fraction I have right here, which is 36 over 54, you would be able to look at that and say, oh, that's not fully simplified. Well, the reason you know it's not is because there's a common factor on top and bottom that you could cancel out. So when I first learned how to do this, I was taught to factor the top and the bottom fully. So I'm going to factor 36. It's 2 times 2 times 3 times 3. And I'm going to factor 54, which is 2 times 3 times 3 times 3. Now I've got factors on top and bottom. Everything on top is being multiplied, everything on the bottom is being multiplied. So anything that's on top and on bottom can be canceled out. So let's see, these 2's can cancel out, these 3's can cancel out, these 3's can cancel out. And that leaves me with 2/3, and that's the fully simplified version of the fraction. Now, this is the same thing we're going to do with rational expressions. The way you simplify is we're going to factor fully, and then cancel like factors on top and bottom. Cool. So if you look below, there are two rational expressions, one that has a monomial on top and bottom, everything's already being multiplied, and one that has a polynomial on top and bottom. You have addition and subtraction. So we're going to do both of these problems together. So the first one, the monomial, they factor just like regular numbers do. So 3x squared y to the fourth would be 3x times y times y times y times y. And then on the bottom, 12 would be 2 times 2 times 3. X to the fifth would have 5 x's. And then y squared would be 2y's. So everything on top and bottom is being multiplied. So anything that's the same on top and bottom gets canceled. So these 3's go away, these x's, these y's, and these y's. So then if you look at what's left, I have a y squared left on top, and I have 4x cubed left on bottom. Now we did this before, and we did it with like doing the exponent rules. I'm just writing it out all the way so to make what we're about to do with the polynomial make a little more sense. Now, by the way, if you look at this original thing, we talked about like a chapter and a half ago, some values that can make fractions like not work. You can never have a denominator equal to 0, right? So when I ask under what conditions these fractions will be undefined, that's what values would make the denominator equal to 0. So you always look at the original and you say, okay, x couldn't be 0 here, nor could y, because both of those would make the denominator equal to 0. So let's look at the polynomial one now. So this one also is going to get factored, but remember, factoring polynomials isn't like factoring monomials. You actually have to do the box or the grouping method or whatever method that you're comfortable with to factor a trinomial. So 5x is 5 times x, no big deal there. But x squared plus 4x plus 3, I'd want two numbers that multiply to give me 3 and add to give me 4. And that would be 1 and 3. And since this has a coefficient of 1 on the x squared, I could just drop those directly into factored form. And then on bottom, I have x minus 6, which can't be factored anymore. And then x squared minus 9, which is a difference of two squares. So it factors as x plus 3 and x minus 3. Now, if I look at this fraction right now, I could go ahead and say what x cannot be, what makes it undefined. X can't be 6, x can't be -3, and x can't be 3. Once I've established that, then I can go back and cancel any like factors. X plus 3 is on top and bottom. And then my rule is, if you were to multiply the thing out on top or bottom and it's quadratic or less, go ahead and multiply it out. If it would end up being cubic or bigger, leave it in factored form. So the top and bottom would both end up being quadratic, so I'd rather write those out. So 5x squared plus 5x over x squared minus 9x plus 18. And that happens when x isn't 6 or 3 or -3. And that would be my answer there. Didn't circle this one, but I did now. So that's sort of like the first piece of this, is know how to factor fully. And then once you've factored, be able to say when it's undefined, and then cancel like factors. So one more thing to think about here. Sometimes when you have a factor, you may have to look a little closely at the factors to make sure that they can't cancel. So let me show you on this one. The first factor that I have up here has a common factor. Always look for common factors. It's really easy to look past those, and it'll make your life a lot harder if you miss common factors. So I'm going to pull out the common factor, which is w. So that leaves me with a 4w minus 3y. And then here I have w plus y, which can't be factored anymore. And that's over 3y minus 4w and 5w plus y. Now, do you notice the factor that's right here and the factor that's right here look almost exactly the same, but all their signs are reversed? The 4w is positive or negative, and the 3y is positive or negative. Whenever you see that, all the signs are reversed. Those are actually the same factor, but one of them is being multiplied by -1. So what I'm going to do is take this, and on the bottom, I'm going to pull out the -1 from that first factor. That would make the 4w positive and the 3y negative. And remember, since I'm factoring it out, I don't have to worry about doing anything to the other factors anywhere. Notice that makes that and that the same. So what I end up with is w squared plus wy over -5w minus y. So whenever you have two factors that look exactly the same but their signs are reversed, consider pulling out the -1, and it'll make it a lot simpler. That's it for now, so we'll talk about multiplying fractions in the next video.